Hello, welcome to adding and subtracting polynomials. Our main thing today, our big objective, is going to classify, add, and subtract polynomials. So let's first take a look at this. So in this particular situation about admission and parking for a museum and an aquarium, some cases you can model situations like this with expressions composed of monomials, okay? Monomial is a real number. It's a variable or a product of real number in one or more variables with whole number exponents. So here's an example of a monomial. So there's one, here's one, this one's just a variable. This one has a coefficient and a variable. This one has a couple of variables and an exponent. We've got a division problem. We have a third of a variable. So monomial really is made up of one term. You can use monomials to form larger expressions called polynomials. So monomial is made up of one. Polynomial is going to be made up of more than one. And we can be adding and subtracting that, and we'll practice that in a moment. Here's a couple things to write down for notes. The degree of the monomial is the sum of the exponents. So the degree of monomial has to do with the exponents. So take a look at that. The degree of a non-zero constant is 0, because 0 has no degree. So the degree of a non-zero constant is 0. So we'll take a look at that. So in these examples down here, we're looking at the degree of each monomial, and the degree is dependent on the exponent. So this guy right here, I'm looking at the exponent, and I see that there is, it's the 1 power, so the degree to this one is 1. And B right here, I have 6 x to the third and y to the second, so I'm going to look at my exponents, bring them together, and the degree is 5. C for 4, there is no exponent, and like we read earlier here, non-zero constant is 0, so there is no exponent, so I would say the degree on this one is 0. And the degree is important when it comes to classifying these and writing them in standard form, which again we will do later. Why don't you try the got it? Press pause and play it out, and let's see how you did. All right, let's take a look. I took each exponent, added them all up in each term, and I was able to identify the degree. Let's keep going. You can add or subtract monomials by adding or subtracting the like terms. So we are combining like terms, but this time we're also considering exponents and variables that are attached to these. So what is the sum or the difference? So let's take a look at A. So A, I am noticing that I have 3x squares and I have 5x squares. So when I combine my like terms, I have 3 and 5, so I have 8x squared is what this simplifies to. Same with this one. I'm looking for in B, I have x to the third times y. I have x to the third times y. I'm noticing that I have 4 of these, and right here I have 1 of those. 4 minus 1 is 3, so I have 3 x to the third times y. So I am looking at, when I'm combining like terms, I am considering everything beyond the coefficient on this one. So got it. Why don't you go ahead and give it a try. Press pause. Combine these terms. All right, how'd you do? I took my -6 and my 11, brought them together, and the reason I could do that is because both these terms are x to the 4th power. Same with the second one, but this one I subtracted to -7 to get my -5, and the reason I could do that is because they were like terms. They were both x to the 2nd times y to the 4th. A polynomial is a monomial or a sum of monomials. So really a polynomial, many, is made up of many monomials. The following polynomial is the sum of monomials. Blah, blah, blah. That sounds like a mouthful, but really what it is it's just a polynomial is a bunch of monomials. So when I look at the degree of each one, now remember the degree has to do with the exponent. So for this first term, the degree is 4 because of the exponent. This one is 2, this one is 1, and that one is 0. And that comes into play. Why that is important is when we are writing these in standard notation, when we're writing up our answer in the right form. And that's what we're going to talk about right now. The polynomial is shown above is in standard form. The standard form of a polynomial, so how you're going to finally write your answer in its last form, means that the degrees, okay, of the monotone terms decrease from left to right. Okay, so once you find all the degrees of each monomials, then you line them up from left to right. So the biggest one is on the left and it decreases down. So this one right here is written in correct standard form where the highest number of degree goes first and then it just keeps going down. And usually the last term in your polynomial is the one without a variable because the degree is 0. Okay, and we'll practice that a little bit. The degree of the polynomial in one variable is the same as the degree in the monomial with the greatest exponent. So the degree of each monomial, you look at each exponent in each term to go ahead and determine, okay, what's the order I put it in. But when I'm asking for the degree of the entire polynomial, when I'm asking for you're looking at something like this and I'm asking, hey, what is the degree of this entire polynomial? You want to consider the greatest exponent. So in this particular model, the greatest exponent is here. So the degree of the polynomial is 4. So we've got kind of degrees kind of going all over the place. The degree of each monomial tells you what order to put it in. The degree of the entire polynomial is dependent on that highest one, that big number. Okay. Now let's talk about a little about classifying each of these. And this is important when it comes to naming them and figuring out what they are. You can name a polynomial based upon its degree and the number of monomials it contains. So for instance, this first one here. This polynomial it's a 0 degree, no exponent. Name using this degree, we'd say it's a constant. There's one term, and we call that a monomial. Okay, we've talked about that. There's just one term there. The second one here, and we've done a lot of that in previous chapters, is this has 2 terms to it. There's 1 degree because there's the exponent right there. There's a 1 in there. And we'd say this is a linear relationship. So the name using this degree is it's a linear. And because it's 2 terms, we say it's binomial. So we would say that this is a linear binomial relationship here. The next one here, notice it has 3 terms. And so we'll call that a trinomial. But when I look at my degrees, I look at the highest one. It's a 2. I call that quadratic. So this one is a quadratic trinomial. We've got a third one here too, where I can see that my degree is 3. But if I have 1 term, so it's a monomial, but it's cubic by the degree, so I would call this a cubic monomial. So cubic, my term, monomial, the number of terms. Sorry, cubic being 3 because the degree is 3. Sorry, my mistake. Let's look at this last example here. So I can see that there are 3 terms, but I look at the highest degree is 4. So at this point, we could just call it the 4th degree. And because it has 3 terms, it'd be a trinomial, so we call it a 4th degree trinomial. And this is something that's it's the language of math. It's classifying what we're looking at. And you'll get used to that as we practice it. All right, I want you to give this a try too. Let's practice a couple of these first. Write each polynomial in standard form. So that helps us determine what it's called. So when I look at these two, I can see this degree here is 1, this degree here is 2, and I want to order it from the greatest to the left. So it's 4x squared plus 3x. Okay, now this is indeed in standard form, and I want to name the polynomial. So this guy right here, the highest degree is 2, and it has 2 of them. And so when I come back and look at my example, I have 2 terms, and let's see what I got here, and I've got a 2 as my degree. Okay, so I've got a quadratic binomial happening here. So the 2 tells me it's a quadratic and it's a binomial. Okay, let's look at the second one. Before I do this, I need to see there's some terms I need to combine a little bit here. So 7, I've got 11 x's actually here. I'm going to look at the terms. There's a 0, there's or the degrees again. So I've got a 1, 3. Okay, so I'm going to rewrite this as in degree order. So there's that one. I have plus 11x, and then I've got minus 1. And when I look at this whole thing, the degree of this polynomial is 3, but it has 3 terms. So I'm going to come back real quick. Using my degree, it's 3, so I can see that it's cubic, and the number of terms is 3, so it's a trinomial. So I would say that this is a cubic trinomial. All right, why don't you try this one? Here's your equation, and let's go ahead and put it in standard form and figure out its name. That's classification. You go ahead and write it down. I'll go back to the last page so you can look at it, and then you can press pause. All right, we're looking at a quadratic trinomial. Quadratic because of the second degree, trinomial because there are 3 terms. Now that we've classified them, we want to be able to subtract them as well. So we want to write this in simpler form. So we've got this one right here, this one polynomial, and we're subtracting this second polynomial with that one. So when we're doing this, it's kind of like adding like terms, but this one we're actually subtracting like terms. So the first method is to stack them vertically. I do like this. You can use either one, whatever helps you. So you want to line up the terms because you want to subtract a term from a term. So x to the third, my first one, my second one, I have a 7. You know what I'm going to do? I'm going to rewrite this because I'm subtracting, and I'm going to distribute that negative out. So I have x to the third minus 3x to the second plus 5x. And again, I'm going to be distributing that negative out. So that's going to be minus 7x to the third minus 5x to the second. I have no term for this one, and then that would be plus 12. And now I can, and I'm going to actually look at this as adding. So there's 12 there. That's 5x. And I have negative 8x squared. And I have negative 6x to the third. Another method I could do it is setting it up horizontally. This would be pretty much looking at the groupings. So I've got this one, and I'm subtracting this. So I've got negative 3x squared minus 5x to the second, which is going to give me the same amount. And then I've got 5x minus, oh, there's no term over here. And then I've got just your minus, actually, so it's like 0 minus negative 12. And let me get that first one too, just so we can see it. So I have x, that's not an x to the third minus 7x to the third. So kind of just looking at it, it's pieces. It's all up to you. And notice they are written in standard form, just because I have the highest degree first written down. All right, I want you to try it. Press pause. I want you to subtract this in either method. Maybe consider trying both if you want. Give it a try. All right, when I subtracted these out, I can see that I have negative 4m to the third, subtracting nothing, so that stays. I have no term for this one, so when I subtract 4m squared, I end up with a negative 4m squared. I have a negative m, and I'm subtracting m from that, and I end up with no more m's left. That term is gone. I have 9 minus negative 12. I believe I have an error on this one, so 9 minus negative 12 is adding, and that would be an error. Let me correct that. 11, that would be 21. So, and I've written this in standard form with the highest degree first. All right, keep practicing this stuff. All right, I'm gonna go ride around in a recycling bin until somebody says, "Hey, you're riding a recycling bin."